Good morning, chemistry students. This is Mr. Arnold again. Hey, today we're going to talk about hydrocarbons. This is day 2 of week 4, which would be organic chemistry, and we're going to talk right now about hydrocarbons. Now, I know you've heard me say this 1,000 times. The words in chemistry say the definition: hydrocarbons. Hydrocarbons are compounds that are made up of only hydrogen and carbon. Right? So hydrocarbon, carbon and hydrogen, and that's it. Now these are really important to us. I'm going to change this font. Uh, there we go. They're really important to us because these are our fuels. Now, if you look down here, I have a little list of what they're like, but let's look at these pictures. Methane gas. Methane is the stuff that comes out of our Bunsen burners, right? It's a gas. It's methane, which means one carbon, so it's CH4. Right? It's the simplest of all the hydrocarbons. One carbon with 4 hydrogens connected. And it burns really clean. That's why we can burn it in class like that and not have to worry about, carbon monoxide as much, because it's the small molecule that burns really clean. It's a gas. It comes out of a pipe in the ground. They usually have it piped to your house, right? That's methane, natural gas. The other one here, the second one, is propane, right? And we all know propane if we're grillers, right? Propane is a small gas, and now this is generically, I mean, there's probably other gases mixed in the actual tank, but this is propane. It is 3 carbons long. Prop means 3, and then it has 8 hydrogens attached, just like that, all single bonds, right? And that's propane. And now if you think about propane, look at this tank it's in, right? It has to be under a pressurized tank. I'm going to erase that. It has to be in a pressurized tank to make it, or to carry it around, right? And as soon as you open that tank up, it comes out as a gas under pressure because they had to pressurize it to turn into a liquid. Okay, now we're going to move right down the list here. This next one is butane, and but means 4. And so this has 4 carbons in a row. And those are all hydrogens on there. I'm not going to draw the hydrogens. I'm just going to draw it like that. I'm going to save some time here. And plus, it takes up too much space. Now, if you ever seen a butane lighter, you realize that the liquid in there is the butane. And as soon as you push this little button right here, you push that button, it causes the gas to escape. It evaporates really fast. Now, it stays a liquid in this tank, and this little cheapo plastic tank isn't very strong, right? So it doesn't take much pressure. It just takes a little teeny container to make it stay a liquid, but it evaporates very quickly. And then we have octane. And oct means 8. Octopus, right? 1, 2, 3, 4, 5, 6, 7, 8. And 8 carbons all in a row is octane. Now, octane is what is in gasoline. Now, the gasoline pump says octane, right? 97% octane. Not all gasoline is octane, though. There's hundreds of different compounds in there, but octane is, we're going to say generically, would be the most abundant, at least back in the old days. And if you know what gasoline's like, right? Gasoline evaporates. It could be a liquid. It could be in a container, and it evaporates really fast. You can see the vapors coming off of it, right? You can see those vapors coming off of it, but you can just put it in a pretty much normal plastic container, and but it evaporates really fast. Okay, now let's look at our trends. Okay, the smaller the molecule, the easier it is to evaporate. As the molecule gets longer, it's more liquid-like. And we could even go beyond this. And normally I go into diesel fuel, which is like 12 carbons, and then you have like coal, and coal can be hundreds of carbons long, right? And so it goes from a gas to a solid the longer the chain becomes, because the molecule keeps getting bigger and bigger. All right, let's look at all of our things here. Back to the list. They have very low melting points and boiling points, and that's the things we said about all these, right? Boiling points, they evaporate very easily. All hydrocarbons are flammable, right? And so that's what we use for fuels. All these down here are fuel sources. Hydrocarbons are nonpolar and mix poorly with water, and we know that already, right? Oil and water don't mix. These are nonpolar. There's no sides to these. It's hydrogens all the way around. Hydrocarbons are our fuels, and I just said that. And they also tend to burn in combustion reactions. So all those combustion reactions we've done, just a second, the dog's coming down. I'm also going to throw out the word volatile. And the word volatile, a lot of people think, oh yeah, volatile means explodes. Volatile really means that it evaporates really fast. But in this case, these gases are all volatile. They evaporate really fast, and what happens is that evaporated gas mixes with oxygen, and we know that from our other chapters, when the fuel mixes with oxygen, that leads to combustion reaction. So because they mix so readily with oxygen in the air, they do explode in the air. And that's why you never pour gasoline or any volatile liquid onto a fire, because it'll evaporate from the container, mix with the oxygen, and the fire then will follow that vapor right back to the can or right back to you. Very dangerous. Be safe. We don't want to hurt anybody, right? Be careful, especially when working with volatile liquids. Okay, so comparing and contrasting. It's always good to compare and contrast, right? So see what you can do with this. How are these the same up here? Look at those. How are they the same? How are they different? And why? I'm going to leave that up to you to do. I pretty much explained it, so see if you can come up with those things and fill that out. That'll be part of that homework too. Okay, so remember, these notes are going to be collected. I'm leaving things blank for you. All right, alkanes. All right, we have some generic ways of naming things in organic chemistry, and ALK, alk, right? That means hydrocarbon. Ane means single bonded. So what is an alkane? It's a single bonded hydrocarbon. All right? Single bonded hydrocarbons. We're going to say that they are saturated. Saturated. Now, this saturated is not the same saturated we talked about in class already this year. We have the same word, saturated, but in this case, we're not going to use it for talking about solutions, like a saturated solution. Instead, we're talking about saturated hydrocarbons. Okay, so the saturation, let's look at a hydrocarbon, right? Now, we have all single bonds. I'm just going to draw 4 because that's convenient. I mean, I could do 1,000. It doesn't matter. Okay, saturated hydrocarbons is talking about the number of hydrogens that can fit on those 4 carbons. Each carbon, remember HONC, H-O-N-C, where hydrogen can form 1 bond, O2, N3, and of course, carbon can form 4. Each carbon can have 4 bonds attached to it because it has those 4 valence electrons. And that leaves us with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens maximum that could fit on those 4 carbons. That's saturated. It has as many hydrogens as it could possibly hold because they're all single bonds in between the carbons. All right, we've heard of saturated fats and unsaturated fats. Saturated fats means that the carbons in those fats are all single bond, and that means they're holding as many hydrogens as possible. And so if it's a saturated fat, it has all these extra hydrogens holding and hanging on to it its maximum capacity. All right, so saturated means holding as many hydrogens as possible, or all single bonds between carbons. Okay? All right. Now, alkenes. I'm going to switch colors because I want to blend. This is school colors anyway, right? Alkenes. There's alk again, right? Hydrocarbon. Ene. Ene means double bonds. So this has at least one double bond, and it's a hydrocarbon. Do I have to write hydrocarbon anymore for the next one? You know it's going to be the same thing, right? So this time it has at least one double bond, and I wrote that a little different because it doesn't have to have all double bonds. It just has to have one double bond. Let's draw that same compound. 1, 2, 3, 4. Okay. So that was butane. I don't know if you recognize it from above. And now we're going to throw a double bond in there. And it doesn't matter where I put this double bond. If I put it in different spots, it'll be an isomer, right? Let's start putting it here, right there. Double bond. Okay, by putting a double bond in there, what we do is we reduce the number of possible hydrogens it can hold. Now, it can only hold 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's look at that. All right, now look at our carbons here. And I know I always have to go over this in class, and I know that a lot of you already got this and you understand what I'm saying, but you look at this carbon, because that's a double bond right there. Each carbon can only have 4 total bonds. So there's 2, 3, 4. We're going to count that same green again. So there's 2, 3, 4. Okay, so that takes the place of 2 hydrogens that could have been on there. And so that is unsaturated. Okay, it's not holding as many hydrogens as it possibly can. It's unsaturated. All right. So let's change that color. That doesn't show up very well in this paper. Let's just make this definition up. Could hold more hydrogens. Okay, now has a multi-bond, right? It has a double bond, or it could have a triple bond. You know what I'm going to do? I'm going to take that definition, oops, and I'm going to copy that, and I'm going to paste that down here right now because it's going to be the same thing, and I like that definition. I'm going to squeeze it over here so I have room to write alkynes. All right, let's change colors again. All right, alkynes. Alkyne, hydrocarbon, and it has at least one triple bond. I bet you saw that one coming, right? And it is still a hydrocarbon, and it has at least one triple bond. It can have more than one triple bond, but it has to have at least one. All right, let's go back to our 4-carbon compound that we've been using. And I'm going to put the triple bond in the middle this time. I don't know why. I just will. 1, 2, 3, and right. And if I had it on the side, if I had it in the first carbon, the second carbon, it would be an isomer, right? But it doesn't matter. We're just doing examples. Look at that. There's 4 spots there on that carbon. That second one is already taken up. The third one is already filled up. And our last carbon gets 4. So now we're down to just 6 hydrogens total. 6 hydrogens, heck, that's not very many. I can draw those on there. All right. And so again, because we have this triple bond, that's 3, 4. That's 3, that's 4. That's 1, that's 2, that's 3, that's 4. Each carbon, that's 1, that's 2, that's 3, that's 4. Each carbon can only have those 4 bonds. And because of that triple bond, we lose a lot of hydrogens. Oops. Oops. There we go. All right, I hope that makes sense. All right. So those are our things. That's an alkanes, alkenes, alkynes. And those are just 3 common things that happen in hydrocarbons. Now we have more. And I drew some notes to these next ones already. I'm going to draw a little dividing line because that seems like the Arnold thing to do. And I'm going to draw this little line, woo, that cuts this off. So when we look at this, you'll say, oh yeah, that's the other part. All right. Now, look at this. Cyclo. And look at the picture. Oh my goodness. Cycloalkane just means, oh, ane. Look, cycloalkane. It's a, I'm going to write it down here below. It's an hydrocarbon. That's the alk. Ane, single bonds. And then cyclo, they're in a ring. Right? So they can be in rings. We know that already. And so this is in a ring. And so cycloalkane are carbons that are all single bonds that are in a ring. I drew some examples, right? Now, look what I did here. First of all, I drew it like we would normally draw it. I didn't draw H's on there. Right? And those little branches to nothingness when there's C's drawn are to H's. Right? But another way to do that would be draw them without any C's at all. You can draw them without the C's. So this is the same structure. And what I did is I drew it without the C's. So each of these little spots here are little invisible C's. And so each time the line bends, it's going to be a C. And not only are the C's invisible, but we also didn't even write the little slashes for the H's. Right? So that ends up being the same compound, and it's just drawn in a much easier, quicker way. Now, yeah, you're like, oh yeah, that looks so easy to draw. They're kind of hard to draw sometimes. So as we get going, if I were you at first, I would probably start with the C's. We'll grow past it really quick, but we'll just keep it advancing as we draw this, and it'll be, it'll be good. All right. Our last special type of hydrocarbon is the aromatic hydrocarbon. Ooh, aromatic, I know you know that means smell, right? If something has aroma, it's aromatic. It has usually we think of a pleasant smell. All right, so this right here is an aromatic hydrocarbon. And the aromatic hydrocarbon is a ring of carbons that does have a smell. It's known for, it's in a lot of different fruity things and smells that we'll talk about the shape later, but it's an ene in this case. It's really called a benzene ring, and there's the ene for the double bonds, right? So it's a benzene ring, and it's a ring that has alternating double and single bonds, right? Very, very popular ring. If you learn anything in organic chemistry, if you say benzene ring, then people are like, oh, benzene ring. They really know their organic chemistry. So that's the benzene ring. Now, here's different ways to draw it. Here's our classic way that we have been drawing all along, and that looks really pretty with this, right? And so you can draw it this way here if you'd like. Here's a version that doesn't have the C's drawn in there, but they have the H's. This third one, they didn't even bother the H's of the lines, the H's or the C's. And the last one, they are showing what we call resonance. And I looked at our new book, and we don't even talk about resonance in our new book. But resonance, I went and talked about it anyway. Resonance is something that we use to show how the bonds really are. Our bonds, we can draw single bonds, we can draw double bonds, we can draw triple bonds, but we can't draw a bond and a half, right? It's just not something that we do. Well, resonance is the way that we show this bond here, because it's alternating double and single bond. In real life, remember those electrons are just being shared like in a cloud around it. Well, they're being shared around here. Well, because of the sharing, and it's a double single bond that is alternating, and there's no extra electronegativity pulling the electrons one way or the other, what ends up is, in real life, they're not really double single, double single, double single. It's really like even. 1.5, 1.5, 1.5. I should say that 6 times, but I'm not going to. Bonds that go all the way around, and we call that resonance. And it's just because, it's not because the compound is special. It's because our modeling method is lacking in some ways, and that's how they overcome that. So I put this as a definition the other day. Resonance is a way to show the alternating double and single bonds, and it's really like a bond and a half. Okay. Hope that makes sense. All right. Our 20 minutes is up. I wish I could talk all day about this. I know you guys know that already. So what we're going to do is we're going to stop this video right here. We're going to call this day 2. Week 4, day 2. I'm going to come back. I'm going to make another video. I've already have it made, actually. I'm going to make another video, and that's going to be week 4, day 3. And that will take us to the rest of the homework for this week. So that's all in the next video where we finish up. We actually get to name some things in the next video. The lecture part is over, right? The hard part's over. Listening to me talk, that's the hard part. The rest we get to name and draw pictures. And so for this next section, make sure you have some way to write or draw with me as I do it. I don't do them all. I'm leaving some things blank for you to do. And then when we finish the next video, that'll be the end of week 4. The school has changed the grading policy, so we're grading 1 week at a time. I'm supposed to give you an hour of assignment a week. So 3 20-minute videos seems to work for me. And there's a few extra problems you might have to do, but it shouldn't take you very long. All right, well, be safe.